For example, if we consider the graph y equals x squared plus 2. Now, y equals x squared plus 2 has a vertex right at 2. It's got the point at 1, 3, and negative 1, 3, and then 6 and negative 6. Or I'm sorry, 3, 6, and 3 negatives. Negative 3, 6. So here is the graph of x squared plus 2. Now, if we consider at the point 0, where x is equal to 0, if I were to look at that graph, it's kind of leveled out there at the bottom. We could draw a line that's tangent to that point. And right now, it has a slope of 0. It's really not changing at that point. It's not going up or down. It's kind of leveled out at the bottom. That's a little different than if I consider the point that's just 1 to the right. Because at that point, it's actually got a much steeper tangent line that could be drawn that barely touches it. And there, the slope of that graph, it's going uphill. It's actually rising 2 and running 1. If I could grab a different color, we could look at this point at negative 1 or negative 2. Looking at the point at negative 2, we see it's very, very, very steep. In fact, the slope there is going to be negative 4. And we'll talk later about how we can actually calculate those exact slopes. But what's interesting here is this graph starts out with a very steep negative slope, and then it levels out and turns into a positive slope, which gets steeper and steeper.